Welcome to Developer Live Level Up. My name is Patrick Wheeler. I'm responsible for product management of Oracle Multitenant. In this session, I'll explain how to bring your application database design to the next level, whether you're starting from scratch or working with an application rich in functionality that's been refined over several decades. Spoiler alert, the key ingredient is Oracle Multitenant. I'll set the scene by explaining the historic compromise of first-generation SaaS architectures, and then I'll talk about the architecture of Oracle Multitenant. Next, we'll look at two major market segments for SaaS applications: cloud natives and more mature applications, typically architected for standalone deployment on premises. Before summing up and moving on, I'll provide a snippet of best practices. In the cloud era, applications are deployed as SaaS. But historically, database architectures for SaaS have involved a compromise. You can either have isolation and agility or economies of scale. You have to choose. SaaS efficiencies derive from consolidation. A primitive consolidation strategy is just to stack a load of databases into a big server. It's not an efficient model because there's a lot of redundant replication of infrastructure between databases, and each must be managed individually. Isolation is poor because the databases tend to compete for resources, and because they're not very easy to resize or move between servers. They're not particularly agile. Virtual machines have better isolation and decent agility compared to the stacked database model. However, they're inefficient operationally and technically. Operationally, you've replaced physical sprawl with virtual sprawl, and virtual sprawl is just as expensive to manage. Technically, each VM replicates a full stack of heavy software for each VM, even at very low loads. So VMs offer better isolation and agility, but no economy of scale. A far more efficient model is to support multiple application backend databases in a single great big database, in a single great big server. There are two basic models, either a schema per tenant or tagging each row with a tenant identifier. You get great economies of scale. Technically, there's no redundant replication of overheads. Operationally, there is only one environment to manage, but there are major downsides. Briefly, isolation is poor because everyone's data is sloshing around in the same database. Agility is poor precisely because this lack of isolation inhibits granular control of individual tenants. It can be very challenging to retrofit this model to an existing single-tenant database. I'll expand on these shortcomings in more depth later in this session. Multitenant delivers the best of both worlds: the efficiency characteristics of the schema or row-based consolidation techniques, isolation comparable to VMs, along with unprecedented levels of agility. Now, let's map onto this chart what are, for the purposes of this conversation, the two major segments in the ISV market. First, applications originally architected for standalone deployment on premises. These fit into the lower left corner. They're typically very mature and functionally rich. Importantly, they represent great investment, both by the vendors who have developed them over the years and decades, and by the customers who have spent vast sums deploying them. These investments must not be overlooked. Next come the cloud natives, the first-generation SaaS vendors. These fit into the lower right corner. Their huge efficiency advantages enabled a compelling cost model. This allowed them to grab market share while closing the functionality gap as compared with their on-prem competitors. Considering first the standalone apps, how could they modernize and compete with the SaaS crowd? Moving to a tenant per VM model seems tempting at first, No app changes are required, so it's a relatively simple upgrade. But, as just discussed, there are no significant gains in economies of scale, so it's very hard to compete in the SaaS market on the basis of cost price. For this market, Multitenant offers an instant SaaS database architecture. No application changes are required. They retain the benefits of isolation and agility of the standalone model and gain the economies of scale that the cloud natives have been enjoying. As for the cloud natives, they already have fantastic economies of scale. The problem is that they've achieved these at the expense of isolation and agility. SaaS built this way involves the highly uncomfortable compromises that we've been discussing. It's bad enough if you started to build your app this way. It's extremely difficult to imagine how you might re-architect an older app, one in the bottom left corner, to adopt this model. This is where Multitenant comes in. Multitenant enables world-class SaaS that delivers the economies of scale of the first-generation SaaS vendors without compromising the isolation and agility afforded by the standalone architecture. In summary, whether you have a mature app, originally architected for standalone deployment on premises, or a more modern SaaS app, Multitenant allows you to have your cake and eat it. This is the ideal architecture for world-class SaaS. Well, if you're prepared to take my word for it, that's it. Thanks for joining this session. Time to take a break for coffee, perhaps. The rest of the presentation is for the more technically curious. If you choose to stick around, I'll tell you how Multitenant delivers all these benefits. To summarize the multi-tenant architecture, applications run unchanged in self-contained pluggable databases, or PDBs. PDBs are simple to clone and to move to and around the cloud. A container database, or CDB, consolidates many PDBs. Patch the CDB and fix all the PDBs it contains in a single stroke. That's operational efficiency. The shared infrastructure model is highly efficient, so you can support more tenants per server. That is technical efficiency. To a security guy, multi-tenant looks like an access control mechanism. In the SaaS use case, that's the focus here, we have a dedicated PDB for each tenant. Each tenant's PDB has its own table spaces and data files. Transparent data encryption, known as TDE, protects data in those files. Each tenant's PDB has its own encryption key. Access to each PDB is via its services. Resource Manager allows us to prioritize these services, both across PDBs and within PDBs. Let's expand on this comprehensive, built-in resource isolation. Resource Manager can control all dimensions of computing: CPU, memory, IOPS, storage, sessions, parallel execution servers, etc. Controls apply both between PDBs and within each PDB. Importantly, particularly for SaaS deployments, you get what you pay for. There's instant, fine-grained scalability with an ability to allocate costs clearly. Resource Manager helps eliminate the dreaded noisy neighbor problem. Silence is golden. And the application vendor can optimize infrastructure utilization by fine-grained control over the degree of resource over-allocation. An extreme case of the noisy neighbor problem is a denial of service attack. This is mitigated because malicious actors are constrained to their own PDB. Let's start at the bottom right of our market segmentation by reviewing a case study of an application suite you may have heard of, NetSuite. NetSuite is a SaaS pioneer who, along with another leading player in this space, basically invented multi-tenancy over 20 years ago. That was long before we had Oracle Multitenant, and so their first generation architecture involved row-based consolidation. I'll describe this in more detail shortly. This is an extraordinarily successful application suite. There are some huge numbers on this slide, and I won't read them all, but these are the sorts of results that ASPs dream about. 36,000 customers distributed across 19 data centers in 11 regions globally. NetSuite has been growing very rapidly. Several years ago, when Oracle acquired NetSuite, they had only 16,000 customers, so they've added 20,000 or so in the interim. Back then, NetSuite faced several immediate challenges. Move to a supported version of Oracle, 11.203 to 18c, their current release at the time. Reduce costs by adopting a more efficient hosting model. Enable better performance and security. This was the plan. In 2018, upgrade to 18c with multitenant. Instances become PDBs. In 2019, split off accounts from shared DBs into their own PDBs. And 2020, remove the legacy VPD design, which is now made redundant with PDB isolation. That's right. Even though they'd invented multi-tenancy 2 decades previously, before we had a database native multi-tenant architecture, it was still worthwhile for them to upgrade to multi-tenant now that it was available. In the next few slides, I'll explain both why and how. This slide illustrates how row-based multi-tenancy works. All tenants are in a single database. The application server pulls connections, all of which are to this single database. With only one database and one connection pool for all tenants, this is why this model is so efficient. But how is the data segregated? Let's say a particular tenant, tenant 2, wants to see his orders. The application server builds the SQL statement by starting with a basic query, select star from orders, and appending a predicate similar to where tenant ID equals tenant 2. As long as you only access the database through the application tier, it works very well. This was the original multi-tenancy architecture of NetSuite. Next, let's expand on the various shortcomings of their first generation SaaS architecture. There are 4 major categories of problem. 1. Talk to any SaaS vendor and they'll tell you that their biggest challenge is tenant mobility. You need to do this for load balancing or to support different upgrade schedules. Unfortunately though, the row-based tenancy model means that all tenants' data is intermingled. So, to move a tenant involves painfully slow row-by-row separation. Next is storage bloat, specifically with indexes. As we've just seen, the row-based tenancy model means that tenant ID is at the leading edge of every index. This means that, with optional foreign keys, even null references involved an index entry. Ouch. We can't overlook performance, of course. But here's the problem. Every query includes a tenant ID predicate, and every index has tenant ID at its leading edge. So it's a target-rich environment for the optimizer to choose from. The problem is further complicated by differing skews in the data between tenants. This is not always reflected in the statistics, because the data is segregated by convention rather than declaratively. To work around this problem, another SaaS pioneer, who shall remain nameless, even wrote their own optimizer. This is madness. We must have invested hundreds of millions of dollars in our optimizer, and they've had to write their own. This means that if we build new optimizations, such as vector transforms, adaptive query plans, auto-indexing, query rewrite, table elimination, table expansion, just to name a few things we've added in recent releases, they can't take advantage of it. Fourth, data isolation. It's non-negotiable, but here's the problem. Everybody's data is sloshing around in the same database. As long as you come through the application stack, data isolation is very good, but native ad hoc queries are problematic. To mitigate this, either you need to implement a sophisticated virtual private database strategy, or you just say that ad hoc queries are not supported. Contrast the pure SaaS model of Oracle Multitenant. Here we have a tenant per PDB. To satisfy the same business requirement, to show orders for, say, tenant 4, the application server requests a connection from the pool to the PDB for tenant 4. Since that is a dedicated container for tenant 4, only the simple SQL statement is required, select star from orders. Incidentally, this is likely to result in a much better query plan. If there is no available connection to the required PDB, then any available connection is retrieved from the pool, reconnected to the appropriate PDB by issuing an AlterSessionSetContainer statement, and then the basic SQL statement can be issued again. For the reasons I've described, NetSuite decided that it was well worthwhile to upgrade to Oracle Multitenant with a tenant per PDB. Here's a simple two-step strategy to illustrate how this can be done. The initial state is a row-based consolidation model. Typically, this is partitioned by hash. Here I'm using color coding for each tenant's rows, which we see all intermingled at first. Step 1 is to repartition each tenant into a dedicated table space. Importantly, this can be done online, that is, without requiring an outage. Step 2 is also accomplished online. Create subset clones for each tenant with only that tenant's data. Even with the right technology, this was a major undertaking at the scale of NetSuite, but it was very much worth it. Here are some of the major benefits: better security, better manageability, better performance, better cost and utilization. For example, there was a 30% reduction in storage by eliminating tenant ID from indexes. Memory is shared elastically between tenants as well, as this graph illustrates. By comparison, there is effectively no ability to share memory between VMs. And so we come to the other major segment in the application space: applications formerly architected for standalone deployment on premises. To illustrate this, we'll consider the example of a notional company named Waltz Maltz. Waltz Maltz is now a successful global franchised operation that basically sells smoothies and milkshakes. They started 60 years ago with a single store in Tulsa, Oklahoma. For more details on this story, I have a YouTube playlist entitled Stale Standalone to Superb SaaS in a short series. Here, I'll briefly touch on some of the main points. Operations are managed by a homegrown application called wmStore for Waltz Maltz Store. Here's an excerpt of the wmStore data model. Each customer's order may include one or more items, each for a specific product on the menu. Each order may be associated with a specific campaign. The business wants to track the relative success of various products and campaigns. Here's an excerpt of the installation script for this portion of the data model. Don't worry about the details of the script, which is probably too small to read anyway. There's a section to install the various tables in the schema, the PL SQL for things like campaign and inventory management, and various items of seed data. The point is that all of this represents considerable investment in IP. So in the early days of the single store, the wmStore application was installed by running the script in a single Oracle database. In this architecture, we start by creating an application container with what we call the application root PDB. In this, we run the standard installation script for the wmStore application, with no changes. We create what's called a seed database, named wmStore seed, and provision new tenants as clones of wmStore seed. So far, it's comparable to the situation with a simple CDB-PDB model. But now let's look at the upgrade situation. Now there is only one copy, the master copy, if you like, of the application installed in wmStore root. To do an application upgrade then, we only need to upgrade that single master application definition. It's then a simple matter to upgrade the tenants by syncing them with the upgraded master application definition. Franchises can sync on their own schedule. There's no need to negotiate a system-wide outage window, which is simultaneously convenient for all franchises. Another very important capability in a SaaS environment is to be able to measure the overall performance of the business in terms of a few global metrics. A typical case with Malts is to assess the success of a campaign. This could be done by counting the number of orders associated with that campaign. To do this, you could run a SQL statement, like this one, to count the number of orders taken for that campaign. You'd repeat this in every franchise's PDB. Maybe you'd write down the answers in a spreadsheet and use that to compute the total. Obviously, this is a rather cumbersome and error-prone process to repeat one franchise after the other. Application Container has a very elegant solution to this important requirement. This is by use of our containers SQL construct. We start with the original SQL statement and modify it very slightly to use containers. We run this just once in application root. What it does is to run the original query recursively in each PDB concurrently and return the results to root where they're aggregated. If I toggle back and forth, you can see how a SQL statement is simply modified to use containers. This is another example of a very powerful manage many as one capability of Application Container. Let's assess the benefits of Application Container. We have all the advantages of the simple CDB-PDB model, tenant isolation, rapid provisioning, technical efficiencies, in other words, more applications per server, and operational efficiencies because DBAs can manage many tenants as one. But in addition, we now have the ability to manage the application definition centrally, the ability to aggregate data across the entire enterprise by using simple queries against the application root. Taleo Business Edition, or TBE, is a very successful SaaS application in the HCM space. With over 5,000 customers distributed globally, TBE was one of Oracle's first SaaS apps to upgrade to Oracle Multitenant. Briefly, in TBE, we consolidate about 200 tenant PDBs per CDB. Each CDB runs on 2-node rack, with 2 cores and 32 gigabytes of RAM per node. To net these numbers out, each tenant requires only 320 megabytes of RAM. We have 50 tenants per core. 50 tenants per core. Compared to a competitor's cloud, with each tenant in a VM instead of a PDB, Multitenant is 25 times more efficient with CPU and 18 times more efficient with memory. And those are just the technical efficiencies. Operationally, we can manage 200 tenants as one for a majority of administrative tasks rather than having to manage them individually. At the beginning, I promised to provide a few snippets of best practice advice. Here's one that's very important for the SaaS space. It's to have a clear understanding of the difference between the cost of delivering your service and the price you charge for it. A great example of this is taking a cab in New York City. Here's what you're going to pay. $2.50 initial charge, 50 cents per 1/5 of a mile, travelling above 12 miles per hour, 50 cents per minute, stopped or in slow traffic. That's it. Nice and simple. Here's what it's not. There's no reference to the cost of running that taxi. Capital costs, such as purchasing the vehicle or the driver's medallion, operating costs such as fuel, insurance, maintenance and tax. That's the taxi company's cost of doing business. Your bill makes no reference to any of that. Likewise, when running a SaaS business, particularly when it's based on multi-tenant, Resource Manager greatly simplifies the cost structure. You have the opportunity to present a simple pricing structure to your customers. Best practice is to use CPU and storage as primary controls. Index other resource controls to these primary ones. Now, one option is to bill on direct cost structure. A great example of this is Oracle Autonomous Database. Here we see a simple price based solely on compute and storage. Another possibility is to bill on simple customer metrics. For example, $150 per user per month. This is more analogous to the New York City taxi example. It emphasizes the business value of the service rather than the cost of delivering it. We've seen how multi-tenant is the ideal architecture for SaaS. It delivers benefits both for cloud-native applications as well as applications originally designed for standalone deployment on premises. The cloud natives gain many advantages: tenant mobility, storage efficiency, performance, technical isolation, resource isolation, granular upgrade options, simple cloning, and all of this is realized without sacrificing the economies of scale inherent in SaaS. Traditional apps have access to an instant SaaS architecture with a SaaS cost model. Importantly, they gain this without sacrificing their customer base, years of investment in application functionality, and their traditional advantages of isolation and agility. Everybody gains strong resource management, clear consumption metrics, simple cross-tenant aggregation, an easy upgrade path to Autonomous Database. No longer do you need to compromise. Multi-tenant delivers isolation and agility with economies of scale. It is the ideal architecture for world-class SaaS. Thank you for your attention during this presentation.